This example, we have a certain tennis player makes a successful first serve 70% of the time. Assume that each serve is independent of the others. If she serves 6 times, what's the probability she gets all 6 serves in? Let's first just ask ourselves, is this Bernoulli trial? 3 things.
Yeah.
So we said, yeah. Can you give me? Constant.
Success.
Okay, what is the success rate? 70%, so constant P. Independence, it tells us they're independent. Remember the third thing? Which are? Very good, right? Successful serve. So in the, I don't know what you call it, the area where you got to serve it, and not, right? So in or out. Okay, so that is good. When I look at the first one, all 6 serves in. So she tosses it up, she serves, what happens? In, all right? Does it again. In, so we're going, so in, and in, and in. How many times? 6 times. So this one is going to be 6 times. So her success rate, which is 0.7, raised to what power? The 6th power. That is really a question from a couple of chapters ago. All right, so take your calculator out, do 0.7 to the 6th power. Do you need one? All right.
Oh,
yeah. 0.117, 118. Confirm? Yes? Excellent. Thank you. All right, questions on A. You guys see I was using green for like the tennis? We never watch tennis in my house, like rarely, except for Wimbledon, because it's the summertime, like kids just watch the TV, right? So my son Andrew, the youngest one, we watched Wimbledon in July, and then like every day when I ask him, even now, I'm like, hey, what do you want to watch? He goes, tennis? I'm like, bro, it's not July. You gotta wait. I'm sure there's tennis. I just don't know where it is. Okay. Exactly 4 serves in. Let's think about this. All right. Is this waiting till the first success, or is this a number of successes out of a number of trials? Right? 4. It's actually, if it was waiting, it would say, what's the probability that the first success would be the 4th serve? That would be waiting until the 4th serve to get your first success. That's not happening here. It's saying out of 6 trials, what's the likelihood she gets exactly 4 in? So that's the number of successes out of a number of trials. So that's binomial. All right. So let's go ahead and write x equals 4. All right. I'm going to leave the space for 6 trials. Choose 4. Again, am I going to do the factorials? No. But you should know that that's going to be a part of the math. Times, what's our success rate is 0.7. So our failure rate is 0.3. What are going to be my powers? To the 5th? No, it says exactly 4. So which one gets the 4? The 0.7, right? The success is 4, and the failures is 2, right? So you should check, Thomas, they should add up to the number of trials, in this case 6. All right, does it matter the order? What if you put 0.3 squared, 0.7 to the 4th power? Does it matter the order? No, but the powers do matter, right? Those do matter which ones they go with. So at this point, I'm going to go into my calculator. And do you remember what function I'm going to choose? Going to go to second Vars, of course. I think A. Why did you say A? Very good, Raul. A, I believe, I'll confirm in a moment here, is binomial PDF. Remember, second Vars, and then scroll down to letter A, binomial PDF. Raul is exactly right. Because it says exactly 4 out of 6, we're going to be doing PDF. Trials, 6. Probability of success, 0.7. How many successes? 4. Go to paste and hit enter. And we get 0.324. Questions on B? I just wanted to put this here. This is my choose function. So technically what this is doing is 6 factorial over 4 factorial times 6 minus 4 factorial. I just want you to know that, like, if you just put that to the left, it's technically wrong, right? If I just put this, that means she's getting 4 successes in a row, and then the last 2 are failures. But does it have to be the first 4 are successes? No, it could be the last 4. It could be the first 2 and the last 2, right? You see what I'm saying? So there are a certain number of ways that there could be 4 out of 6 successes. It's not really wrong, right? I mean, the key thing is I went to the technology, but I just want you to know that if you just write that, that math is wrong. Let's do letter C. At least 4 serves in. What's the likelihood she gets at least 4? So that would be 4 out of 6 or 5 out of 6 or 6 out of 6, right? So what's the complement to that? 3 out of 6, 2 out of 6, 1 out of 6, or all of them are out, right? That would be not great. All right. So when I see that at least, you know I'm going to be finding the complement. So let's find the probability of x equals 0 through 3. All right. And remember, Raul said we did binomial PDF because it was exactly. Is this exactly 4 now? No. So we're going to be using letter B, which is binomial CDF. Now, the tricky part is when you go to binomial CDF, second vars. All right, so I'm clicking binomial CDF, letter B. I know we still have 6 trials. Probability of success is 0.7. This is where students will make a mistake, right? CDF, whatever number you put in, is going to do that number and all the numbers below it. All right, so if you put in 4, it's going to include 4, and 3, and 2, and 1, and 0 out of 6. Do we want it to include 4? No. So that's where you think, and I think Estrella said this yesterday, maybe Carolina said it, you're thinking always one less here. All right, so if it says at least 4 out of 6, I'm thinking put 3. All right, so this will tell me 0 out of 6, 1 out of 6, 2 out of 6, all the way up to 3 out of 6, the number I put. Hit paste. All right, is that my answer? No, 0.256 is not my answer. All right, the complement now, 1 minus 0.256 will give us what we want, which is 0.744. Questions on C? All right, let's do D. No more than 4. No more than 4. The likelihood she gets no more than 4. So what would be numbers that would work for that one? No more than 4. Would 4 work? It would work, right? No more than 4. We can do 4, though. Right? So in this case, what am I going to use to do? You said 0, 1, 2, 3, and 4. CDF, but what number am I going to type in? I'm going to type in 4 because this time I want it to include 4. So this is the probability of x equals 0 through 4. So this CDF, same process, but we are actually typing in the number. So just be careful. Think about it. I've been showing you guys out loud. I like to think, okay, what numbers does this mean? And then use that to help me decide. So second vars CDF. And this time we are going to type in 4 because we want to do 0, 1, 2, 3, 4. So that's going to be 0.580. Okay, any questions on the first page? There is a back page. I know, excited. So when you're ready, you can flip over to the back side. All right. Same tennis player, right? So what is her rate of success of getting those serves in? 70%. So that's still the same. But this time, they're telling us a different number of trials. How many times is she serving in a match? 80 times, okay? So what are the mean and standard deviation for the number of good first serves expected? So in this case, we're talking about the number of successes out of 80 trials. So I'm thinking still binomial here. And again, I have this memorized. Does anyone know the formula to find the average, the mean? Trials, that's what we're looking for. The number of trials times P. You could write P times N, Jonathan, I don't care. But they'll give you N times P. All right, so in this case, that's going to be 80 trials times her success rate, which is 0.7. I'm doing 10% of 80, which is 8. 8 times 7, 56. Let's say serves. All right, and those are the ones that are in, all right, that are successful. All right, now for the standard deviation, do you remember the formula we're going to use for that one? So trials times the success rate times, you remember what Q is? 1 minus P, which another word for 1 minus P, which is Q, which is complement. Yes, also good. Yeah, but there's the letter F I'm thinking of. The failure rate. Thank you, Johnny. The failure rate. I mean, so many different words. We don't know what you want. Sorry, too loud? My bad. I know it's early. Oop, parentheses. This one I don't know off the top of my head. I'm going to need your help. I'm hearing 1 point, 4 points, sorry, 4 point. So 1, then 0. So 1, 4.1. 4.1.
It's a mystery.
What's up, Sam?
How you
doing, man?
I'm doing good. How you
Yeah, come on in. Let's do some stats.
Oh, man.
Come on, have a seat right there. I'm almost done. All right. Questions on, sorry, the mean and standard deviation. Everybody good? Okay, let's do the last one. Verify that we can go from binomial to normal. What do we have to check to go from binomial to now using the normal model? Very good. Success, failures. You're going to be famous, Sam. I'm recording this. Sorry, your seat is not available. Oh, my goodness. Do you want to come up and do it? No, okay. So we have 80 times 0.7, which we already found, which was 56. And then we have 80 times 0.3. $24, thank you. Victor, do I like these numbers? Are these making me happy?
No.
They're not making me happy? Numbers, first off, numbers always make me happy. They add up to 10. They definitely don't add up to the 80. But they're both 10 or higher, right? So that means our number of trials is large enough that if we wanted to use the normal model, we could, okay? Now here's the deal. We're going to do C. Do you guys see C? All right, let's do this twice. All right, let's do it with the binomial. Victor, don't shake your head. Let's do it twice. Once the binomial, the way you know, and then also with the normal model, which we did in chapter 6 many months ago. So if I wanted to do it with the binomial, what am I thinking when I see at least 65? Complement. So let's find x equals 0 through 64, right? I got to go one less on this one because 65 actually is what I want, or higher. Okay? So let's go to CDF. So second vars. CDF. Don't forget to change your trials, guys. It's 80 trials now. And we're going all the way up to 64. Change your trials to 80. Did you guys? Nice. Yeah. Remember, you're going like twice as fast as we are. Yeah. Is this my answer? No, we got to do what? Subtract it, so we get point. That's not what I wanted. 984. Subtract from 1. What'd you get?
0.016.
Bless you, bless you. Now, if you want, you can put your pencil down. All right, I'll do this with the normal model and see if we get the same thing.
Do we need to use the normal model on the test?
On the AP exam? Oh, yeah, for sure. Right, but I'm just showing you that your technology can do this, Thomas. Right, remember I mentioned yesterday that really this idea of moving to the normal was because many, many, many years ago, you couldn't do this, but now we have the technology. All right? You definitely can use this on the AP exam. Yeah, on every question if you want. Many of them, it won't be helpful. Right? All right, who remembers the formula to get a z-score? I am funny, right? Wait till 2 weeks. I'll put Z. I'll give us that start. Something with a mean, yeah. Something with sigma. Yeah, that's sigma. Over sigma. You guys are doing great. Making me look really good. I'm going to put Y minus, but you can put X. X is fine. Minus the mu. Very good. All right. You actually will get this formula, but it won't be written like that. So you should probably just have that one memorized. Okay? We're trying to standardize 65. What was the mean? What was the mean from 56? So 65. Oh, you wrote it already. And what was our sigma? 4.1. All right, so let's standardize. And I know that I'm doing something bad here because I'm using the rounded number. So, don't give me mean comments on the video. 2.195. Oh my gosh, I'm about to draw the normal curve. Where is this z-score? Not in the middle. Middle would be z-score of 0. It's to the right, pretty far to the right. Which way am I shading? At least, so at least would be that, or more, so to the right. Oh my gosh. Oh my goodness. Now we're about to go to the calculator. Second bars. Which one? I'm truly almost done. It's one of those, Thomas. Are we shading? Did we shade? Yes. So we got to do which one? CDF. Our lower bound was our z-score. And what's our upper bound? We're shading to the right. Infinity. So I'm going to put 9999999. Oh my goodness. God, this is amazing. What am I hoping to get? I have the answer already. What am I hoping to get? Thanks for that. It's helpful. No, I already know the answer. What is the answer? 0.016. So I'm hoping to get that or something close. 0.014. Did I though? Do we not think those are close? Pretty close. But which one is right? They're both right. Which one's more right? The one in green, yes. Yes, because I definitely rounded, but even if I hadn't rounded, it still wouldn't have been this, right? Remember, the normal model is an approximation. So if you can use the binomial, right, then it's going to be the right one. Sorry, Monica. Questions? What